Welcome, friends, and welcome back to the channel. Today, we're going to be deep diving into event-driven architecture, which is the leading pattern for microservices designs and systems. So let's get started. First, we're going to start with the concept. What is an event? Event is something that happens. Generally, it's communicated with an event notification to all the subsystems. For example, if you have an airplane lane and touch the tarmac, it would send an event saying that the wheels touch the tarmac to all the subsystems on the aircraft. On the other hand, we have commands. Commands expect actions to be response to it. Generally, and a good example is you want to turn something on and get a response that's been turned off. A light bulb will be a good example. On is if it's turned on and you want to get notified. Both event and commands, we generally combine them into what's called an event message. Since they're both equal, they're just different between the type of data that is sent along with each object. They could be have sensor information, notification, or just plain data itself. But note, very important note, that the event messages are immutable, which with that forms the basis of our event-driven architecture. There's three main components to event-driven architecture. Producers, which published event that it's going to be received by the broker. The broker is the middleman that's going to coordinate all the events and distribute them to all the consumers that have subscribed. And the consumer will be able to process that data independently of knowing that the producer is still active. This is generally referred to as a publish and subscribe model, or we refer to as a pub and sub. So let's take a look example. We have our aircraft and the tarmac. The airplane lands on the tarmac. An event is triggered called wait on wheels. The wait on wheels producer publishes the event to the broker. The broker then takes that event with the data saying, oh, the wait on wheels is true. We want to distribute that to all the subscribers, and all the subscribers can concurrently get this event and start processing the system. Let's take a look at another example. We can also have multiple producers and multiple subscribers doing multiple different topics of the system. So when first the subscribers register to what message they want, and the producer will be able to publish, and they'll be able to receive that event going forward. So let's take a look at all the benefits of event-driven architecture. We have three main benefits: decoupling of components, dependency inversion, and scalability. So let's take a look at our first example. We're looking at a service A and service B in a traditional model of a REST interface where the first server is tightly coupled to the second service. What that means is when the service B blows up, take out service A at the same time because of this hard coupling that it has. So how does this solve with event-driven architecture? Well, we still have service A and service B. Now we add the broker in the middle of the service. This helps us decouple the components from each other. So now service A is all it needs to worry about is publishing, and service B is all it needs to worry about is just consuming that data and subscribing to that data events. By default, this also creates an inversion dependency. So we're no more tied together at the lowest layer. We're fully abstracted from both each other. So now let's take a look at how that works. Service B subscribes and service A publishes. Once they receive by the broker, it will then publish it back to the subscriber B. This also helps us with scalability. Since the events are immutable, we can also add as many clients to the system that get subscribed to the same data and be able to receive the data in parallel and be able to process it concurrently at the same time, as well having no dependency on it. It also solves us with another scalability problem is when, for example, service D decides to have an issue and restarts automatically. Well, service D then is able to grab the event of the last checkbox where the event's been stored and be able to retrieve the last event or be able to go back into a specific marker and process that data and continue to function without the interruption of service A. Now let's take a look at some of the challenges and considerations. We're going to be looking at three main ones: ordering and timing, complexity, and debugging challenges. So let's start off with our service A and B. As traditional interfaces, the timing is generally predictable. When you have a REST as microservice from to a microservice going, with any type of adding a third broker into it, there will always be a delay. The delay might be very simple. So think of it: service A is publishing the message, and then service B gets it. So the time is usually in very milliseconds or into seconds. So, but there's always a delay that you need to worry. Because of this and being immutable, you can have all the other services, multiple servers getting it, and they will get it at different times and rates. This is called eventually consistency, where all of them will align and start getting all the messages across. But one of the others will get it at different times, which really makes the data to be out of sync potentially and really brings in the extra complexity with the system challenges, since you don't know when it's supposed to, if there's timing, time requirements. So keeping that in mind. Now, let's look at ordering. When a service, for example, gets restarted, say service C decides to reboot and then appears, we are going to be coming that data could come at different points in time. Depending, it could come at the very first or in the past. In this example, we're looking at the data you're going to get through is a little bit in the past, and you'll get the first two as well. So what will happen is the data is injected, and you need to start processing it, and you're going to see some potential duplication and out of order data easily with an event system. So your subscribers should be able to keep in mind to implement idempotent pattern into it, making sure that it can handle the duplicate messages. Generally, events will have a source of event ID assigned to it that will be able to help correlate the data easier. Final thoughts. While the system evolves, don't forget to the schema of the events and data might evolve. So keep a close eye, making sure when you design your subscribers, they can handle the change in the schema going forward. Event-driven architecture is not for everything. If you're not looking at high scale or distributed architecture or some sort of notifications or alerting systems, that might not be the right choice. So let me know in the comments what you guys liked and didn't like about the video and what you like me cover. So thank you for watching. Looking forward to see everyone in the next video. Don't forget to like and subscribe.